Yes, sir.
There was one that seemed like it had multiple answers.
All right. He hasn't taken it, so I would not give him any advantages if I were you. Any advantages you give Mr. Dietrich might help him and might hurt you. Yes, this was a test grade. No. Why would I do that? Okay. This is a new chapter. This is optimization. I may not have moved it over yet, so let me see if I have. Oh, boy.
I would have had to do really bad.
Yep.
You feel like you did go to the test?
Okay, so we're talking about optimization. I believe I told you you've got three. You have three FRQs this week, 24, 25, and 26, due Friday. You've got a homework over optimization that's due Friday. Now, that doesn't mean wait until Thursday night to work on all of that, okay? I'm just asking you to pace yourself over the week here. We're going to begin talking today about optimization problems, otherwise known as word problems, okay? Otherwise known as word problems, problems with words in them. So students did not like these types of problems. What I have found over the last few years is that students are getting better at these, which tells me that our teachers are doing much better before we get to AP Calculus of introducing these and calming your fear of working through word problems. So I like optimization problems because many of them are much more real life than anything you've ever worked with before. And you'll find the ones that I like, find the ones quickly that I like that because I like to talk about them more, such as the first one that we're given here. Traffic control. On a given day, the flow rate, F, on a congested roadway is blah, where V is the speed of traffic in miles per hour. What speed will maximize the flow rate on the road? What on earth is the question talking about? Yes, sir.
What it's asking is at what speed, what is the max, in that question, what is the max speed, what can you put in for V that will give you the largest possible answer?
Yes, but what does that mean in real life?
It means what speed you have all the cars go, that means that they'll be moving through the fast. Yeah.
That's right. This is what the speed should be to make the congestion as small as possible. Okay? So we can keep going better. So, your initial thought might be, well, everybody should be driving 75 miles an hour. The faster you drive, the better flow rate. Wouldn't that sound logical to a certain degree? And also think about I-285. Everybody likes to drive 75 miles an hour on there, except where? Where I-20 merges into 285, or where I-85 merges, and suddenly you're driving down the road at 75 miles an hour, and everything comes to a dead stop. And you creep along for 5 or 6 miles, and there's no wreck anywhere, and nothing, and suddenly everybody's going 80 miles an hour again. It's because there's people trying to merge over to get off or merge on to get on. So those type things. So this formula here purports to take those things into consideration. So what we're saying here is whatever number we come out for this particular road winds up, will tell us this would be the best. If we could get everybody to drive this speed, then the flow rate would be better. People would be able to consistently drive at the same speed. There should be less traffic, slow ups and speed ups and slow downs. There should be less accidents and all. So what are we going to do to solve this problem? Do you see any words that tell you something you should do? Yes. Trying to find the max. Well, how do we find a max? Take the derivative, and what do we do with the derivative? Take the derivative and set it equal to 0. So why don't you do that for this problem? Take the derivative and set it equal to 0 and see what happens. How are we going to take the derivative of this creature? Low D high. We have to use the quotient rule on this, okay? Don't forget that. All those lovely skills that we learned about how to take derivatives, we still have to utilize those. Now we said take the derivative. What are we going to do from there? Set it equal to 0. Do we have to worry about any other cases? When it's undefined. And since we've got a fraction, we think there could be an undefined here. Can you look at this and determine where it's undefined at? It's never undefined, is it? Because what are we doing to this function here? We're taking a number and squaring it. So that means it's going to be a positive number or 0. We're multiplying it by 0.02, so it's still going to be a positive number or 0. And then we're going to add 22. So the bottom has to be positive. So we don't have to worry about undefined. We just need to worry about where the numerator is equal to 0. So let's see if we can figure that out. We've got 22 minus 0.02 v squared equals 0. 0.02 v squared equals 22. V squared equals 1100. I do believe. Because I've got plus 0.02 v squared minus 0.04 v squared. When I'm combining this term right here with that there, that'll be minus 0.04 plus 0.02. Won't this v, I've got a v out here times a v here, right? And now I need to take the square root of that, which is plus or minus, what's in it? Anybody know? You've got a calculating device maybe? 33, okay? Can we throw the minus away? Why? Yes, the velocity is going to be, well, I mean, if all of them were driving backwards at 33, wouldn't it give you the same effect? I mean, technically it would, but we don't normally think about that yet.
Yeah, but I don't think that would work. I don't think a bunch of people driving backwards would work the same way as a bunch of people driving forward.
Yeah.
That's
That's right. Well, we will just assume that we're going to go with a little logic here and say it's 33. Now, do we know that that's the maximum flow rate? That's right. We do. We don't until we do something to figure out that it's a max, okay? So we need to do the easiest thing to do would most likely be a sign line for the derivative. Here's 33 miles an hour, and we've got 22 minus 0.02 v squared, and we've got 22 plus 0.02 v squared squared. Or actually, we write that as 1 over that, don't we? Those two things multiplied together give me my derivative. Well, we know that that fraction is always positive. Agreed? We know that the fractions are always positive. Okay, group those together for me. Group. We know those fractions that the bottom one's always positive. What happens when I put a number smaller than 33 in here? Now, you've got to be a little bit careful here because there's no domain explicitly stated but you should infer that the velocity has to be bigger than 0. Okay? So it wouldn't be wise to put 0 in here. Probably put 1 in there, that would be okay. 1 squared times 0.02 is a really small number, and 22 minus a really small number, that's positive. So that means the first derivative is positive before 33. Is there an upward bound on the 33? Really, no, there's not. But I mean, the cars probably can't drive 500 miles an hour. So just pick a number bigger than 33. Maybe, 40. 40 squared is 1,600, and 0.02 times 1,600, I think, is 32. Yes. So that'll give you a negative number. So that tells you that 33, since the first derivative is positive, and then it becomes negative, this tells you that that's a max. So the flow rate can be maximized if you can get everybody to drive 33 miles an hour. That means we can get more people on the road, more people moving through the intersection, or whatever the case might be, if you can get everybody to drive 33 miles an hour.
So basically, set the speed limit equal to 30 miles per hour and watch everybody drive faster.
Could be. Yes, sir, ma'am?
Is that why we have the speed limit that we have?
Good question. Is that why we have the speed limit? The answer is I don't know. I think a lot of the speed limit is driven by accidents and by studies that say, when people are driving faster than this, then more accidents occur. But some of it will have to do with flow rates like this, because when you get into smaller confined spaces, you need to slow down because of just the spaces and all. But I don't really have an answer. I would imagine they do some of this type of stuff to figure it out. Yep, you're absolutely correct. But when they have an accident, boy, is it a doozy. Yeah.
So, you have less accidents, but you always have bigger accidents.
That's right. It's like the big one at Talladega every year. Okay, look at the next problem there for a moment. See if you can work out and get a solution for A part without any input from me, okay? I was afraid you were going to read ahead and think of that. Let's look at A part first, and then we'll talk about B part, because there is a subtle difference there.
The rate of growth. Okay.
Good. I'll let you explain that to us in a moment. Bless you. Bless you. Can someone share with us what you're doing, not what you've gotten, but what you're doing for A part? Find the amount of money companies should spend on advertising in order to yield a maximum profit. So you're going to take the derivative and set it equal to 0, okay? You're going to find that I just said is going to be said over and over and over and over and over again. Find the derivative, set it equal to 0. Negative 3/10 s squared plus 12s. We set that equal to 0. Now we've got to factor that thing. How are you going to factor that? Took out an s, So we get negative 3/10 S plus 12 equals 0. First one's easy. We get S equals 0. Do you think that's a max? 0. Why not?
That would be, but I prefer just to go ahead and, according to
That would be the max.
if you, because you can't, in the words of whoever said this, you can't make money out spending money.
Right. If that's the max, that means we don't need to advertise in order to make money, okay? So it wouldn't logically sound like that would be the thing to do. Now, are there companies that maybe that holds true for?
Like the companies that you pay
Yeah.
to advertise.
I mean, Apple didn't have to advertise 3 years ago. If you think about it, you never saw a commercial for Apple on television because people were standing in line to buy it. Suddenly there's commercials for Apple now, but 3 years ago you didn't have to do that. Okay, so let's keep going here. Negative 3/10 S equals negative 12. So S equals 40, I do believe is what I get out of that. 40. So if we were to do a sine line, our points are 0 and 40. We've got S, this is P prime, and we've got negative 3/10 S plus 12. Well, it's negative out there, it's positive there, it's positive there. If I put a negative number in here, negative times negative is going to be a positive, plus a positive, that'll be positive. So if we spent negative numbers, if we could spend negative money, the profit would be going down. That doesn't make any sense, but mathematically, that's what it means. What about if I put 1 in here, or maybe 10? 10's less than 40. Negative 3/10 times 10 is negative 3, plus 12 would make it positive. So I'm going up all the way to 40, and then after 40, let's put 60 in there.
20, so negative 8, so
Negative 8, so it's negative, right?
maybe it's not negative.
If I put 60 in here, 10 will go into 60 6 times. 6 times negative 3 is negative 18. Negative 18 plus 12 is a negative number. So that means positive times negative is negative. So we've got a maximum profit if we spend $40,000 on advertising.
If in the end you end up with like one of the ones that kind of bottoms out at a point and then keeps going up, I think it's when it's cubed.
Well, then you.
Then it's an infinite.
Yes. So if this had been positive over here, that means it's the more you spend, the more you make, okay? But this says that in order to maximize our profit, we don't want to spend but $40,000 on advertisement. Think that's a good thing for businesses to know? I mean, suddenly there's no reason for us to keep spending money. Are we going to make more money after $40,000? No, it's just this is just for a specific one. Are we going to make more money? We're going to gross more money, but we're not going to make as much profit for whatever reason. Okay, so let's look at B part now. The point of diminishing returns is the point at which the rate of growth of the profit function begins to decline. Find the point of diminishing returns.
What would that be? 40?
All right. Mr. West, do you want to try and enlighten us on this?
Well, it's the rate of growth, so it's the second derivative.
It says the rate of growth of the profit begins to decline. The rate of growth means P prime. P prime begins to decline. That's what another way to say this is the point of diminishing returns is the point at which P prime begins to decline. So how do we figure out when P prime is declining? Find the second derivative and set it equal to 0. So B part means find the second derivative of this thing. The second derivative is negative 6/10 S plus 12. Yes, you could simplify it to negative 3/5, yeah. And now if we do that, we get S equals 20. What does that mean? That's the point of diminishing returns, but what does that mean? That's when the rate of growth begins to declining. But in real life, what does that mean for you as a business owner?
The results are not going to be as clear. I mean, that's the point at which, like, spending more money is starting, you're still making money off of it, more money off of it, but you're starting to make less.
Exactly.
The amount of money you're making is slowing down.
Exactly. We're still making more profit, but yes, it's the inflection point. But but the rate at which it's growing is smaller. So really, what this would tell me as a business owner, okay, the first $20,000, pretty much I can spend that on anything on advertising, okay, because my profit's going to be rising there. From $20,000 to $40,000, that's probably where I want to target target marketing, okay? So I'm not going to just put up a billboard with that last piece of money to get the most for my most bang for the buck. I'm going to go and target the people that are going to buy it. So instead of putting an ad in the newspaper to sell Apple Watches, I'm much better off to put something on television or on Facebook or on Instagram. Why?
Because people are more upset to buy Apple Watches and more doing that than reading the newspaper.
Is Grandpa that's been reading the newspaper for the last 45 years going to buy an Apple Watch? Probably not. That's right. So you use this information to target who you're going to approach with what you're doing there, okay? So 20 is the point of diminishing return. The key thing for y'all to remember here is, how did we know it was a second derivative? It says the rate of growth begins to decline. The rate of growth is P prime. P prime begins to decline. So sometimes you need to look at these problems and reword them into math terms there. Okay, this one's not nearly as exciting, but it's something that you need to be able to look at and do. Find the length and width of a rectangle that has a perimeter of 80 and a maximum area. Okay?
So what two factors of what two numbers to add up to 40 multiplied together to give you the biggest number?
Right. Area is length times width. Okay? Now, and we said to find the maximum area. Right? Well, maximum says find the derivative and set it equal to 0, right? What's the problem with finding the derivative here?
That would make it a square, wouldn't it?
It's okay to be that, yeah. But somebody answer my question. What's the problem with finding the derivative of this thing here? We've got 3 variables here. Okay? What happens when we have 3 variables there? Now we've got to use implicit differentiation. Now we've got length times the derivative of the width plus width times the derivative of the length. So this becomes a challenging problem for us to do with just that formula. So we need to find out what constraints are there.
L plus W has to equal out to 40.
Okay? And how do you get that?
Because for a rectangle that was full perimeter of 80 meters, the length and width together have to equal half of the perimeter.
Right. This first statement says find the length and width of a rectangle that has a perimeter of 80. So you've got to dig back into your geometry. And remember, length and width are dimensions on here. To find the perimeter, we say 2 times the length plus 2 times the width equals the perimeter. So if we know that, then we can get to what Mr. Wells said, L plus W equals 80. Excuse me, 40. Does everybody see how I got to that? Just dividing everything by 2 there. Well, now how does that help us?
Now we know the
Okay? But what does it help us to do in this math problem now?
You can put them all in.
By one side.
Solve this bottom equation here for L or W. Does it matter which one?
Nope.
Solve it for one, plug it in, chug it out, okay? Go. Solve it for L or W. I don't care which one. Substitute it back into the area, find the derivative, set it equal to 0, find your critical points, determine if they're maxes or mins, blah, 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 blah.
When this is rectangle, it has to be a rectangle, like.
Yes,
Square.
a square is a rectangle,
But I'm breaking.
but a rectangle is not a square. Yes.
Harder than I know what it is.
Okay, yes. But, and you're right, y'all are smart enough to be able to look at this. Several of you have already figured out it's got to be a square. And you're right, you're smart enough to know that with this particular problem. It's wise for you to be sure you can work through the math to get to that conclusion, to prove that conclusion, because you won't have anything this nice and neat on the test necessarily, or an assessment or anything like that. So we're going to say area is length times 40 minus the length, which is 40L minus L squared. So area is A prime. So that equals 0 when L equals 20. Therefore, W equals 20. And by this point in life, we've gotten lazy, and we might do a sign line, we might not, okay? So if you do a sign line, that means you are doing well. You should probably do a sign line to be certain of this, but some of us are going to be lazy and not do that. Okay? Right here. I can take this equation right here and solve it for W. W is 40 minus L. Then I can plug it back into that right there. Yep, I jumped a step there on you. Again, if you're doing a sign line, think about your constraints on the domain. What's the smallest that L could be? What's the largest that L could be?
1 in 79?
1 in 79. I don't think L could be 79. Because if this is 79, that over there is 79.
Oh.
See, your L has to be between 0 and 40. Would you agree with that? Because if it's 41, if this is 41, if this side down here is 41, then the side up here is 41. That gives you 82, and that means your width is -2, whatever that means. So we can't have that. So we'll pick a number smaller than 20, like 10. 40 minus 20, that makes it positive. We'll put a number bigger than 20, like 30. That makes it negative. Therefore, this is a maximum. So we know that the maximum area would be a 20 by 20 square. Any of this seem complicated yet, people? I don't think it is either, especially because y'all are so smart. Sometimes you just have to be careful in reading them. So I'm going to give you a moment to read over this problem, see what you can come up with, and then I'll have one of you come up here and work through this for us, okay? We're probably only going to work a couple more problems today, yep. Yeah, probably 2, 3 problems, something like that. So y'all work it out, and then one of you is going to come up here and work it out for us and explain it to us and all that jazz.
What does it mean by what dimension should be?
What should X and Y be in this particular problem? What are we trying to maximize, class? The area. So what's the area of this figure that we have here?
2x squared y. You got 2 x's on one side.
All right, I hear xy, I hear LW, I hear x squared y, I hear 2xy. Only one of those can really be workable for us here, okay? Okay? It's the length. It is length times width, but how long is this? It's 2x long, and how wide is it? Y. So I think we will be better served to write down for our area 2xy. All right?
Anything in the middle between the two, should you calculate that into your 200 feet?
You've got to make a fence in there, yeah. Let's be sure everybody's comfortable with this 2xy. Okay? Now, you could say that the area is xy plus xy because you've got two corrals there, but you still, eventually, you should wind up with 2xy. And just like the last problem, or problem here, I think it was the last one, we've got two variables over here, so we need to find a constraint. What constraint do we have?
4x plus 3y equals 200.
Right. We've only got 200 feet of fence. Now, 4x plus 3y has to equal 400 because we're going to make 4 sections of fence, bless you, that are x long, bless you again. And we're going to make 3 sections of fence that are y long. So when we add all those up, they've got to be 200. So now we should be able to, just like we did in the previous one, solve 4x plus 3y for x or y, it does not matter which, and substitute it back in. What did everybody solve for, x's or y's? How do I get 3y? I've got this, the middle piece, and that. So I've got 3 pieces in there. Easy to miss that. So if we solve for x, we get 200 minus 3y over 4. And we put that into our area formula. We get 2 times 200 minus 3y over 4 times y. I think that's Coach Myers. Wow. Okay. So our area is 200y minus 3y squared all over 2. Is everybody comfortable with that? Because I canceled the 2 on the outside with one of these down here. Now, I don't like the quotient rule. So I'm going to do something to get rid of the quotient rule here. Good question. Could you just get rid of the 2? You can kind of do that. I would probably change this into 1/2 times 200y minus 3y squared. Now when I do first times derivative of second, that half's not going to play any difference in it. But when I do second times derivative of first, derivative of half is a 0. So I know I don't have to worry about that. So I know A prime is 1/2 times 200 minus 6y. I'm going to set this equal to 0 anyway, so the 1/2 is not going to make a difference. So I get 6y equals 200. So y equals 33 1/3. I made it 1/2 times this, just by factoring out a 1/2. And I did, if I had done the quotient rule, I'd still get there. It's just uglier. If I had divided these out and said it's 100y minus 3/2 y squared, I'd still get to the same place. No matter what I do, I'm going to wind up at the same place there. With these, it's important to answer the question that was asked. Okay? It said, what are the dimensions? So y is 33 1/3. How do we figure out what x is?
Plug it back into the, 3y plus 4x equals 200 probably.
Right.
So you solve it from there.
We're going to plug it back into this one here. So if we say 4x plus 3 times 33 1/3 equals 200. If we work through that, we get x equals 25. So the farmer should use 25 and 33 1/3 for the dimensions there. Do you think the farmer's going to really pull out his calculus and do that? Probably not, okay? But he could if he wanted to. That's right. You just put it together there. And realistically, the farmer probably does do some calculus, but it's stuff that he's just learned in his head that he has to do. I mean, builders use trig all the time, but they don't know the sine from the cosine from the tangent, but they use it all the time. All right, any questions about that one? Am I going too fast? Okay, the next one's a little thought-provoking, so it'll be our last one for the day, okay? A rectangular page is to contain 24 square inches of print. The margins at the top and the bottom are 1.5 inches each, and the margins on the left and right are 1 inch each. What should be the dimensions of the page so that the least amount of paper is used? Okay? So someone has done a study and said, we need 24 square inches of print on the page. That makes the books about a size that people like to read, an amount they'll read in a time frame. So that's how much we want on the page. We want to make the page a minimal of size, though. And we've got to have these margins so they can write in the book or whatever. How do we accomplish this? So.
Wait, why is the y coordinates x and the x coordinates are y?
Don't question math, Robert.
Say that. Oh, I see what you're saying. Yes, x should be this way and y should be this. Yes. Okay. All right. Okay, we're going to change that. Okay, we're going to change this letter to y because y's normally go up and down. We're going to change this letter to x because x's normally go left and right. Okay. Now, tell me something that you're going to write down here. That means area. Okay. Okay. Y plus 3 times x plus 2 is the area, and I'm going to put a little subscript here, page. Okay? It's the area of the page. Because y is this amount, you've got to add the top and bottom margins. X is the horizontal amount, you've got to add the inch and the inch.
How do you know the dimensions of the least amount of paper used if you're considering, like, if you don't know how big the book is? Does that even matter?
But that's what you're trying. Oh, we want to know the least amount of the minimum size for this page here. Not the number of pages, but for this size page right here.
Okay.
We're trying to figure out what size the book should be to make it, to use the minimum amount of paper to still get 24 square inches on each page there.
Oh, so the minimum is...
It's not the minimum number of pages, it's
We're
the...
trying to figure out the x and y value of the print.
That's, yes, we want to know how many inches across are we going to print and how many inches down are we going to print.
So the 24 inches squared is not the area of the page.
No. It says a rectangular page is to contain 24 square inches of print. So what gives us 24 square inches?
Y plus x.
Yes, so we know that x times y has to equal 24. Now we've got the difficulty with this initial equation that we've written here. The difficulty with taking the derivative of that is we've got 3 variables in there. Mm-hmm. So now, with this constraint down here, We should be able to solve it for one of those variables. Do you want to solve it for X or Y? Y, okay. Y is 24 over X, so we're going to plug 24 over X back in up here. And it gets kind of interesting here. We have 24 over X plus 3, X plus 2 equals the area of the page. So we've got to work that out. How are you going to take the derivative of that? Okay, you can do the product rule, you can multiply them together, and then do whichever you want to do. If we do product rule first, 24 over X plus 3 times the derivative of the second, 1, plus second, X plus 2, times the derivative of the first. What's the derivative of 24 over X? That's negative 20, excuse me, that's right. That's the same as 24x to the negative 1, so it's negative 24 over x squared. Well, that looks like fun to deal with, doesn't it? And we want that to be equal to 0. 24 over x plus 3 plus, if we distribute, let's use a different color. If we distribute there, we get minus 24 over x. Are y'all comfortable with me saying that? If we multiply negative 24 over x squared times x, that x in the numerator will cancel with one of the x squares in the bottom and give us minus 24 over x minus 48 over x squared. All of that equals 0. That's not looking any better, peoples. Now it suddenly looks better. This thing cancels with this thing. So now we're down to 3 minus 48 over x squared equals 0. So that means 3 equals 48 over x squared. 3x squared equals 48. X squared equals 16. X equals 4? Wow. Who'd have ever thought that we could get to a nice number like that with all of that ugly stuff?
Oh, it did work out. Because I did X, I had my X's and Y's.
Uh-huh.
I did that with 6.
That's right. I was going to say, now how do we figure out the other one there? Well, 4 times 6, y has to be 6. So the page has to be 4 by 6 to get 24 inches, square inches.
Yeah, Gabby writing it would get us there.
The pages.
What?
Gabby writing it would get us there.
Okay.
She writes like max.
Ah.
Wait, is this right? Am I right?
Can everybody get there?
Is that how the derivative?
Yes, sir.
Okay.
Uh-huh.
Why do we end this the main one? Why
Ah,
not?
very good question.
We do the sign line?
Yes, to be absolutely, positively sure, we would want to do a sign line on this lovely thing, okay? I'm going to accept on faith that it's right and not do a sign line. Yes, sir. Okay, one of us is wrong.
I got X equaling out to the dimensions of the text, which is what that was for X and Y. I got X being equal to 3 and Y being 7.
Okay, that can be right then. Y plus 3, X plus 2. All right, X, Y, 24. It's not, those don't add to give you A, they multiply to give you
No,
A.
that's just something I did my own work up here, because when I figured out that these are the possible variables for the size of the text.
No, it's not.
Mm-hmm.
It could be 3.5 page, 3.5.
But I also got 4, but I did get 4 and 6 as one of them, and when I compared them, I figured out that if you added the dimensions of the page, and then you found the area of the page with that, the area of the page for one that had text of 3 by 7 was 4 smaller than if you had text that was 4 by 6.
But 3 times 7 doesn't give me 24.
My mistake.
Yeah. But now, did we answer the question that was asked? Hint, hint, wink, wink. What should the dimensions of the page be? That's right. The page needs to be 6 by 9. Okay? The page needs to be 6 by 9. All right? Okay, we're not going to work any more problems in this today. And we're going to pick up right where we left off here and work through the last 5 or 6 problems on Thursday, the next time we meet. You've got the homework 24 that you could begin working on right now if you chose to. You've got the 3 FRQs due Friday that you could begin working on if you chose to. And you've got a WebAssign due Monday that you could begin working on if you chose to. You do not have enough knowledge based on what I have taught you alone to complete the homework or the WebAssign. You may be brilliant enough to figure it out on your own, but you've not been taught enough to do that. FRQs you should be able to complete on your own as they are. So.
What is the difference between related rates and optimization?
Excellent question. Who can tell us the difference between related rates and optimization? How do you tell the difference? But I understand what you're saying. When you read the problem on the test in May, when you really read it, how are you going to know this is related rates and this is optimization? Anybody got any ideas yet? Okay, I'll let you think about that and I'll answer that question on Thursday. What's that?